Okay, so we are finishing out the HiSet Free Practice Test Math FPT 6A, and right now we're on question number 19. Question number 19 says, the amount of hot cocoa powder remaining in a can is 6 1/4 tablespoons. A single serving consists of 1 3/4 tablespoons of the powder. What is the total number of powder remaining in the can? So what we're going to have to do is we're going to take our 6 1/4. That's how many is left in the can. 1 3/4 is how many a serving actually is. Okay, let me make sure I read that correctly. Yes, I did. Okay, so what we're going to have to do is see how many of these will go into that. Okay, the easiest way to do this is to change everything to an improper fraction and then divide your two fractions. The way you divide fractions, well, I'll tell you about that when we get to it. First of all, let's take these mixed numbers and change them into improper fractions. Okay, so with 6 1/4, what we're going to do first is we're going to multiply the 6 by 4, and then we're going to add the 1 to it. So 6 times 4 is 24, plus 1 gives us 25 over 4. So that's our first improper fraction. Our second improper fraction is 1 3/4. We're going to multiply the 1 and the 4. 1 times 4 is 4. Then we're going to add the 3, and that's going to give us 7/4. So that's our second fraction. Now what we're trying to do is figure out how many of these will go into this. So what we're doing is we're taking 25 over 4, and we are dividing it by 7 over 4. A little trick whenever it comes to dividing fractions, if you don't remember this, you need to put it to memory, is that whenever you're dividing, what you're actually going to do is take your second fraction and flip it and then change it to a multiplication problem. So let me rewrite this. We have 25 over 4 times 4 over 7, because we flipped this one so that the bottom is on the top and the top is on the bottom. Now we're just going to multiply straight across. I like to take the shortcut with things, so I'm going to cross multiply, and I'm going to end up with 25 over 7, which is not one of the answers that they gave to us. They gave us the answers in mixed number form. So we're going to go back and change this improper fraction back to a mixed number. To do that, we're just dividing. So 7 will go into 25 3 times. I'm going to change my colors here. It will go in 3 times. 3 times 7 is 21. And there is a 4 left over. So our number is going to be 3 4/7. Okay? 3 4/7 is going to be your answer. Now we're going to go back and check our answers and look at that. B is 3 4/7. Number 20. Let me get a new piece of paper for number 20, because 20 is going to ask you to organize some things. And when we're organizing things, you want to use different colors, you want to use different, whatever, however you want to do this, okay? So we have a basket. I'm just going to start writing these down as I'm reading them. The basket has 2 apples, so I'm going to put down 2 apples. Okay, it has 3 bananas, so I'm going to put 3 bananas. It has 6 oranges, 6 oranges. I'm going to put OR so I know that's not a 60. And then it has 4 pairs. 4 pairs. Okay, this is all of the fruit that's in the basket. It says all of this is in the workroom. When Miss Hutchinson went into the workroom, other workers had already taken 1 banana, 2 oranges, and 1 pear. So I'm going to subtract those from what's on there. So they had already taken 1 banana, 2 oranges, and 1 pear. Okay? So now I have new numbers for all of these. Now the question is, from the remaining fruit, Miss Hutchinson randomly took 2 pieces of fruit from the basket. If each fruit is equally likely to be chosen, what is the probability that the third piece was an orange if the first 2 that she took were also oranges? So she's going to take, I'm just going to write this over here, she's going to take 3 pieces. The first 2 are oranges, and the question is, will the third also be an orange? What is the probability? Okay, I'm going to go back to my numbers that I have right here. Let me clean this up just a little bit. Get rid of this line because it's kind of in my way, even though you understood what I was doing with it. Okay, so we have 2 apples plus 2 bananas left plus 4 oranges plus 3 pears once we subtract out all the pieces that were already taken. So whenever she gets to the fruit bowl, this is how many pieces they have left right now before she does anything else. So there's 2 plus 2, which is 4, plus 4 is 8, plus 3 gives us 11. So there are 11 pieces of fruit to start off with, all right, after other people have already taken the fruit. She takes 2 pieces of fruit away, okay? Those 2 were both oranges. So when she takes those 2 away, that means that there's 2 oranges left, all right? 11 minus 2 is going to give us 9. So the question is, what is the probability that she will get an orange for the next piece of fruit? Okay, there are 2 oranges left out of 9 possible pieces of fruit. Okay, so she has a 2 in 9 chance that her third piece of fruit is going to be an orange. So it is a 2 in 9 chance. Question number 22. We're looking for an equivalent phrase or an equivalent expression. So all you're doing with this one is you're going to you're just going to simplify it a little bit to see what's going on. Okay? Remember that you can only divide expressions that are like each other. I'm going to show you what I mean by that. Let me get a new piece of paper and I'll show you what I mean. Okay? So we are going to paste this right here. Okay. This is the question. Which expression is equivalent to 6x squared plus 4x over 2x? The first thing I want you to notice for this whole entire thing is that this is a fraction because it has the line right here, and it's not just a fraction, it is a fraction where we are adding 2 terms. What that means is that we actually have 6x squared over 2x, and we also have 4x over 2x, okay, because the 2x is our least common denominator. So if we were to separate it out, it would look like this. A couple of things that we've already done in previous videos is we have taken the bottom exponent and subtracted the amount from the top exponent. So I'm going to show you how to do that. And we have also taken these first expressions and divided them by each other. So 2 will go into 6 3 times. If I take 1x away from 2 x's, I end up with 1x, okay? 2 will go into 4 2 times. I keep my plus sign. And if I take 1x away from 1x, I'm left with 0 x's. So this is going to be the answer as to what is equivalent to this right here. Okay? I'm moving very quickly through these last few questions because they actually are a little bit faster questions. The next one here is going to blow your mind, I promise. Okay? Let me move my screen. There it goes. Okay. All right. So, which set of ordered pairs represents a function? With this, it should only take you a couple of minutes to figure out which set of ordered pairs represents a function. And I'm going to take you through it just to show you how this works. But then once you figure it out, it will be really simple for you to look at it, okay? So what we're looking for a function is that a function cannot have the same x repeated twice. So let me say that again. A function cannot have the same x repeated twice. So let's just go through and see. Let me take a quick picture here. And I'm going to move it onto my board so you can see it. Let me erase what I did just a second ago. And I'm going to add my picture. Okay. Now, I am just going to see what is going on here. Okay. So I'm going to get a green pencil and mark things out. Okay. -5 for -5. A is not a function. B, -1, -1, -1. B is not a function. C, -3, 2, -7. That one's a function. D, 2, -2, -2. That one's not a function. And E, 2, 3, 2. That one's not a function. So C is our answer because all of the x's are different. Okay, the x's have to be different. So we have -3, 2, and -7. So that's the reason why C is the answer for number 23. Moving on along, I skipped number 21. I skipped number 21 by accident because of the way this test is written out, and I'm kind of trying to finish this up. So for this one, let me take a picture of it for you. And I'm going to move it onto my board. Here we go. I did not mean to move it on top of the other stuff, so let me erase all this. All right, so the family is driving. They're on a road trip, and the family is driving 348 miles. That's how far the trip is, okay? 348 miles. They've already driven 208 miles of the trip. That means that they have 140 miles left to go. It says they drove 65 miles per hour. That's at 65 miles per hour for the first part of the trip. And we want to figure out how fast they went for the next part. The total trip was 6 hours, so I'm going to write down 6 hours. Okay, now I'm going to get my calculator and show you what we're going to do here. Really, really simple math. If we went 208 miles at 65 miles an hour, we have to figure out how many hours that was. So that was 3.2 hours. So it took us 3.2 hours to go the first 208 miles. Now we know that we went for a total of 6 hours. So we're going to take our 6 hours and subtract 3.2 from it. And the rest of our trip is going to be 2.8 hours. And that is how long how long it's going to take them to go the other 140 miles. So now all we have to do is divide 140 by 2.8. We'll do it really quickly. 140 divided by 2.8, and it gives us 50. 50 miles an hour is how fast they went.